Okay, this lesson is lesson 4, chance experiments with outcomes that are not equally likely. The sample space for the paper cup toss was on its side, right side up, and upside down. The outcomes for an experiment are equally likely to occur when probability of each outcome is equal. So we're going to toss a paper cup 30 times and record in a table the results of each toss. Now, I already did this, and here were my results. I had side, 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 um, right side up, side, 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 upside down, side, 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 upside down, side, 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 upside down, side, side, right side up, upside down, oops, yep, side, 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 and side. Okay, so that was my experiment. So based on that experiment, okay, here is what we needed to do. It said, using the results of your experiment, what is your estimate for the probability of the cup landing on its side? So the probability of it landing on its side was, to count it, our denominator is 30. So to count them, I had 1, 2, 3, 4, 5, 6, 7, 8. I had 24 of them. So simplifying that goes to 4/5. Then it says, using the results of your experiment, what is the estimated probability for it landing upside down? We had it on its side, so now the probability of it landing upside down. Again, my denominator is 30. So upside down, I had 1, 2, 3, 4 of them. So that would be 2 out of 15. And then the results of our experiment, what was the probability of right side up? And for that, I had, I believe, 2 of them. 1, 2. I did have 2 of them, which would equal 1 out of 15. It says, based on your results, do you think the 3 outcomes are equally likely to occur? No, I do not. Okay. Now, it says, using the spinner below, answer the following questions. Are the events spinning and landing on 1 or 2 equally likely? Yes. Section 1 and 2 are equal. Okay. Now for the next one, it says, here we go. It says, are the events spinning and landing on 2 or 3 equally likely? No. Section 3 is larger. It says, how many times do you predict the spinner will land on each section after 100 spins? Well, in order to do that, we've got to figure out, to land on 1, that would be 1/4 of the time, or 0.25. For section 2, that would be 1/4, or 0.25. And section 3 would be 1/2, which would be 0.5. So for that, to multiply that times 100 would be 0.25 times 100 would be 25. 0.5 times 100 would be 50. So for section 1 would be 25 times. Section 2 would be 25 times. And then section 3 would be 50 times. Now next it says draw a spinner that has 3 sections that are equally likely to occur when the spinner is spun. How many times do you think the spinner will land on each section after 100 times? Well, to try and draw it as best you can, you don't have to be an artist. Okay. And that's the best I can do there. So you would try and do it by the center here. Go down this way, down that way. Okay. It's trying to be 3 equal parts. Okay. Then when we do that, it would be 1/3. Okay. So 1/3 times 100 would be just about 33 because it's 0.333 repeating. Okay. So about 33 times in each section. Okay. So next, now we're going to work with some tables here. And when we work with a table, the one thing you want to make sure of is to make sure that when you're looking at the table, if it's talking about a probability, which it is here, that this adds up to 1. So let's start with what the question is. It says, when Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table below. So when we add this together, add in your calculators, but 0.1, 0.1 and 0.1 is 0.3, plus 2 is 0.5, plus 2 is 0.7, plus 3 is 1.0. So we're okay, it adds up to 1. It says, what is the probability that Jenna buys exactly 3 bananas? So we want the probability of exactly 3 bananas. Well, here are the number of bananas, 3, so our answer is 0.2. We're just looking at the table. So next we want the probability that Jenna does not buy any bananas. So the probability of 0. Well, that probability is 0.1. Again, we're just looking at the table. Next it says, what is the probability that Jenna buys more than 3 bananas? So in other words, we want more than 3 bananas. So we can buy 4 and we can buy 5. So that would be 0.2 plus 0.3, which equals 0.5. Okay? So next, well, I want to keep that there. Okay. What is the probability that Jenna buys at least 3 bananas? So we want to include 3 this time. So greater than or equal to 3. So that would be 0.2 plus 0.2 plus 0.3, which would equal 0.7. Here it says, what is the probability that Jenna does not buy exactly 3 bananas? Here you could do this one of 2 ways. Because this all adds up to 1, we want not 3. We can actually take the 1 and subtract the 3, which is 0.2, which equals 0.8. The other thing that we can do is what it says down here. It says, notice that the sum of the probabilities in the table is 1 whole, and it equals 1. This is always true. So when we add up the probabilities of all the possible outcomes, the result is always 1. So taking 1 and subtracting the probability of the event gives us the probability of something not occurring, which is what this is. If you feel more comfortable, the other thing that you can do is add up everything but 3. Either way would work. Okay. Next. So here again, we would add up our table once we start. Jenna's husband, Rick, is concerned about his diet. On any given day, he eats 0, 1, 2, 3, or 4 servings of fruit and vegetables. Probabilities are given in the table below. Here's his probability. Okay. Add that up. Make sure that it adds up to 1. I added it with my calculator, and it does add up to 1. So now it says, on any given day, find the probability that Rick eats 2 servings. So that would be 0.28. Make sure that you put in this, ladies and gentlemen, that's very important. Next, it says more than 2 servings, so the probability of more than 2 servings. So we have 3 and 4, so we're going to add those together. So we have 0.39 plus 0.12, which then equals 0.51. Next is at least 2 servings of fruit, so the probability of greater than or equal to 2 equals 0.28 plus 0.39 plus 0.12. And remember, because it's all adding, you can add them all up at once, and it's 0.79. And then find the probability that Rick does not eat exactly 2 servings. So P is not 2. Therefore, 1 minus 0.28, which then equals 0.72. Okay. Now we have another table. Here, though, ladies and gentlemen, we have fractions. Okay. There we go. And again, this equals 1. And because you have a calculator, ladies and gentlemen, again, same thing here. Okay. So the probability, we have Lewis works at an office and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and their probabilities are given in the table below. Here we go. So find the probability that Lewis receives 3 or 4 phone calls. So we have the probability of 3 or 4. So we're going to be adding those together. So 1/3 plus 1/9. And that would give us 4/9. Finding the probability that Lewis receives fewer than 2 phone calls is the probability of less than 2, which would be 1/6 plus 1/6, which would then equal 1/3. To find the probability that Lewis receives 2 or fewer phone calls, so the probability of less than or equal to 2 would be 1/6 plus 1/6 plus 1/9. That would equal 5/9. And then finding the probability that Lewis does not receive 4 phone calls, so not 4, would be 1 minus 1/9, which would equal 8/9. Okay. So next we have our table again. Okay. Here we have, excuse me. When Jenna goes to the farmer's market, she also usually buys some broccoli, the possible number of heads of broccoli that she buys, and probabilities are given in the table below. Again, this equals 1. Find the probability that Jenna buys exactly 3 heads of lettuce. So the probability that she buys 3 heads of, broccoli is 1/4. The probability that she does not buy exactly 3 heads of lettuce. So the probability of not 3 is 1 minus 1/4, which is 3/4. Then we have buys more than. Oh, let me fix that light. Okay. So buys more than 1 head of lettuce or broccoli. Oh, I keep wanting to say lettuce. So more than 1 head of broccoli would be 5/12 plus 1/4 plus 1/12. And that would equal 3/4. Or buys at least 3 heads of broccoli. Which would be 1/4 plus 1/12, which when simplified would be 1/3. Okay. So now, next, the diagram below shows a spinner. Designed like the face of a clock. The sections of the spinner are colored red, blue, green, and yellow. Well, they're labeled red, blue, green, and yellow. Okay. So we're going to be answering some questions regarding that. And here they are. Okay. So we have writing our answers as fractions. Okay, writing our answers as fractions. Okay. In lowest terms, find the probability that the pointer stops on the following colors. For it to stop on red, the probability would be 1/12 because there's 12 sections. To stop on blue would be 2/12 or 1/6. To stop on green would be 5/12. And to stop on yellow would be 4/12 or 1/3. And let me bring that back and show you why. Okay. For red, it would be 1/12. For blue, it would be 2/12. For green, it would be 1, 2, 3, 4, 5/12. And for yellow, it would be 1, 2, 3, 4. Okay. And that's how I got those numerators. Okay. So now it says complete the table. So we're just basically going to write these fractions in here. So red is 1/12, blue is 1/6, green is 5/12, and yellow is 1/3. Okay. So then it says find the probability that the pointer in either the blue in either the blue or the green region. Okay. So we got the probability of blue or green. So in that case, we got blue is 1/6 plus green is 5/12, which would be 7/12. Okay. Then we have find the probability that the pointer does not stop in the green region. So we have probability of not green. So that would be 1 minus 5/12, which would equal 7/12. Okay. And that is our lesson, ladies and gentlemen, for today.